So some of these themes, some of these things that we're hearing about, we've been hearing about over and over and over again. That's part of the beauty of this class. It builds on itself so we can remind ourselves of what we know. So what are the components of all cells? You got to have your plasma membrane. You have to have your cytoplasm. You have to have your DNA. And you have to have some organelles of some kind. So what is that plasma membrane? That is a membrane that surrounds the cell and controls which substances get in and out. It's called selectively permeable. We looked at those phospholipids last time. We looked at that membrane with the phospholipid molecule. Because those hydrophobic tails get together, those hydrophilic heads get on the outside of the membrane, you end up creating this semi-permeable membrane. Cytoplasm. You just heard it right now on that animation. It's a semi-fluid substance that's inside the cell's plasma membrane. It's the area between that plasma membrane and the DNA. It's where all the metabolic functions in the cell occur. Cells have to have DNA. We know a little bit about that, and we're going to learn a lot more about that. Cells also have organelles. These are structures that carry out specialized metabolic functions. Okay, they can have membranes or they cannot be membrane bound. We'll be looking at details of bacteria cells, prokaryotic cells, details of eukaryotic cells, both the plant and the animal, throughout this week. And we'll get to see some of these organelles that are membrane bound and some that are not. Okay. When you have a membrane enclosed organelle, it allows you to compartmentalize tasks. It allows you to build and modify and store substances. Let's take a look at that prokaryotic example, and then we'll go on to the eukaryotic cells later. So, do anyone remember what's unique about the prokaryote? Something about the DNA, the nucleus, or there's nucleoid? There is no nucleus, right? There's no membrane-bound sac that the DNA is in. It's kind of in an area that some call the nucleoid, and it belongs together. So that makes it a prokaryote. It's without a nucleus, okay? These cells seem to appear to be less complex because they have less specific organelles that are doing specific functions. Okay? It's a simpler cell. So they do have what? All the components. They do have the cytoplasm, the DNA, the plasma membrane, and the organelle, the ribosomes we were talking about. So they do have those still, but they don't have a lot of really specialized organelles that we'll look at later. When we look at a eukaryote example, we remember what's unique about a eukaryote. It has a membrane-bound nucleus. It has a nucleus. We see that we have DNA just like before, but it's in a nucleus this time. We still have the cytoplasm. We still have membrane-bound organelles. Like this is the Golgi. We still have the plasma membrane. Okay? We still have all those components. It's just that you can see from going from the bacteria or prokaryotic cell to this cell, there's a lot more detail, a lot more specialization going on here in the eukaryotic cell. So cell size is really interesting. Cells must be small enough to be efficient at exchanging materials with their environment. They're doing work. They're breaking down and generating molecules of life that you need to function. They have to be able to move that around, and they have to be small enough to be efficient at it. So a surface to volume ratio limits cell size, and it influences cell shape. So if you get too big and you have too large of a surface area and your volume's really massive, your messages can get lost. Okay? So The definition of surface to volume ratio in cells is this relationship in which the volume of an object increases with the cube of the diameter. Okay, but the surface area only increases with the square. Let's take a look at it. Don't get like, whoa, cube, square, what? I thought this was biology, not math. We're not big into the numbers around here, okay? We're just trying to understand the relationship that, yes, it's valid that the cell has to be confined. It can't be massive, okay? It has to be confined. So that's all. So when we have this relationship is shown in this table where we have a cell with a diameter of 2 centimeters. We have a surface area that has 12 and a volume that has 4.2. You can see when we go up here and we get super, super, super large, we end up with a surface area and a volume that are 1-to-1. Okay? And when we start to get too large, beyond that, the cell is not able to send the messages that it needs to send.